We've all seen it in the movies, right? Characters popping up as these three-dimensional light forms, talking and interacting like they're actually in the room. Well, what does it take to make that happen for real? Turns out that science fiction is getting really close to science fact, and it's all going to be powered by the next generation of wireless tech, 6G. This quote here is from a company called Kaleda, and they're one of the pioneers already making this stuff happen. Imagine a CEO appearing live on stage at conferences on 3 different continents at the exact same time, or a product reveal that just floats in midair looking totally real. The ability to create a jaw-dropping visual hologram, that's already here. And that is the crucial question. See, showing a pre-recorded image is one thing, but capturing, sending, and then rendering a person's life-sized 3D image across the globe with basically 0 delay, that's a whole different ballgame. It requires a fundamental leap in how we think about communication. So here's how we're going to break it all down. First, we'll look at the dream of holograms as it is today. Then we'll get into why 5G just can't get us there. After that, we'll dive into the near-field breakthrough that changes everything, see the hardware they're building for it, and finally check out the wild new reality that 6G is going to unlock.
All right, let's start with where we are right now. The dream of holograms is already taking shape. And believe me, it's way more than just a cool light show for entertainment. It's actually becoming a serious tool for big industries and communication. So today's holographic world is kind of split into 2 camps. On one side, you have companies like Kaleda and HyperVSN, and they're focused on these amazing displays for things like advertising and big events. Then on the other side, you've got tools like Microsoft's HoloLens, which overlays digital information for engineers or surgeons. But here's the thing they all have in common. They pretty much rely on models that are already loaded or on local processing. That real-time, coast-to-coast conversation, yeah, that's not quite there yet. And that brings us to the core problem. To make those holographic calls truly interactive, life-sized, and in real time over a network, we need a massive, massive upgrade. And it turns out, even with all the hype, 5G just isn't going to cut it. We've basically hit a technological wall. I mean, if you just look at how wireless has evolved, each generation gave us something new. 1G was voice, 2G was text, 3G got us on the internet, 4G brought us video streaming, and 5G is connecting all our smart devices. But the jump to 6G, it's not just about being a little bit faster. It's about enabling a complete merger of our physical and digital worlds. So where exactly does 5G fall short? Well, it really boils down to 3 huge problems. First, delay, what the engineers call latency. For a hologram to feel real, you need less than 1 millisecond delay. 5G is closer to 5. Second, 5G is mostly built for downloading. A hologram needs to upload a gigantic amount of 3D data from you. And finally, 5G's architecture just isn't flexible enough. It was never designed to do something this crazy. So how do we get there? Well, the answer lies in a really fundamental shift in how we use physics. We have to go beyond the way we've always thought about radio waves and start using something called the near field. Okay, so every wireless device you've ever used, your phone, your Wi-Fi, all of it, operates in what's called the far field. Basically, far away from the antenna, radio waves flatten out and travel in a general direction, kind of like the light from a big floodlight. But in the near field, really close to the antenna, those waves are actually spherical. And that curve, that's a superpower. It contains information about distance. It means you can focus energy not just in a general direction, but to a precise pinpoint location. And here's what that looks like in the real world. The picture on the left is the old way. That flat, planar wave just spreads out like a floodlight, spilling energy everywhere and causing interference. But the near field on the right, that's the game changer. It's a focused, spherical wave. We've basically switched from a floodlight to a laser pointer, and we can target a signal to a single person with incredible precision. So, at its core, it's all about how close you are. Right next to the transmitter, you've got these powerful, curved, spherical waves. As they travel farther away, they flatten out into the plane waves we've used for 100 years. For pretty much all of modern history, engineers thought of that near-field zone as just messy noise to be ignored. 6G is about to turn it into our greatest asset. And here's the critical part. You can't just get this with a software update on your phone. Harnessing this new physics demands a complete, from-the-ground-up reimagining of the hardware that sends and receives signals, from the giant cell towers
all the way down to the tiniest chips in our future devices. So, if the theory is solid, how do you actually build it? Well, right now, researchers are tackling the huge challenge of taking this complex physics and literally shrinking it down onto tiny working chips. This quote from a researcher, Michael Kaiser, it just perfectly captures the problem they're facing. They're trying to create these antenna-in-package solutions where the antenna and the computer chip are in the same little module. But there's a catch. The chip needs room, but the size of the antenna is locked in by the laws of physics. It's a massive miniaturization puzzle. The key piece of tech that unlocks the near field is something called an extremely large-scale antenna array, or ELAA for short. We are talking about arrays with a huge number of tiny antennas all packed together. And that's what gives the system the power to create and control those precise spherical waves. So why does a giant antenna array matter so much? Because the bigger the array, the bigger the usable near-field zone gets. And get this is a total game changer. With an antenna array just the size of a door, the near field extends over 100 meters. That's longer than a football field. All of a sudden, this isn't some tiny lab experiment. This is a practical tool for covering entire buildings, maybe even city streets. Okay, so we've got the theory, we've got the hardware on the way. What does this all add up to? Well, by harnessing the near field, 6G is ready to unlock a whole new connected reality, enabling things that until now were purely science fiction. And the payoff is a world where the line between what's physical and what's digital just disappears. They're talking about teleportation, not the Star Trek kind, but real-time, life-sized holographic experiences. Or creating a digital twin of a jet engine so you can test it to failure without ever touching the real thing. This tech will be the backbone for truly driverless cars and will create a way smarter Internet of Things with everything connected seamlessly. But the impact is even bigger than just these specific apps. 6G represents a whole series of fundamental shifts in how we think. We're moving from networks that just offer you services to networks that are built around you, the user. We're going from systems we control manually to smart networks that learn on their own. And we're going from flat 2D coverage on the ground to true global 3D connectivity that includes things like drones and satellites. And that's the ultimate takeaway. More than any technology that has ever come before it, 6G is being designed from day one to seamlessly merge our physical and digital worlds, creating one single integrated reality. So, it's really not a question of if this technology is going to arrive anymore, but what we're going to do with it. The physics is being worked out, the hardware is being built, and the potential is, well, it's almost limitless. So the final question really isn't for the engineers, it's for all of us. When our digital and physical worlds finally merge, what are we going to create?